Yeah, Sai, can you please ask Shravan to join? Hi, Venkat and Ajay. Good morning. And good evening. Just 2 minutes. Uh, Sai, can you please ask Shravan to join?
Yeah, two
Yeah.
minutes. No.
Okay. I sent message to her. So let us see. Fine. So she has some internet outage issue. So she's okay for recording. We'll continue. Yeah. So anyway, I got the message from her. Yeah. Fine. Let's continue now.
That's not responding. She not
No,
responding.
no, I got the response. She responded to
Oh,
me. So she has some internet outage issue. So she is okay with the recording. Yeah, fine. We'll continue. Fine. Okay. So I think in the last session we talked about like how to read the data from a file, get it transferred to a file. And second, we've also talked about like how to take care of database configuration part. like installation part, and then connector, then configuring JDBC driver name, it's a jar file name, then configure the connection properties, then use those properties to pull the data. I think we have done that. Yeah. Today, we will try to talk about XML, which means how to read the data from an XML file and get it transferred to a flat file or relational table. Yeah. So that's a question. Because nowadays, on most of the what you call applications or tools, we go with what dealing with what real time data transaction, right? Or real time data integration, the context of data integration. In order to perform the real time data integration, so we have to think of two options. One, so we need to go with either XML or a JSON. So these are the two formats through which we could able to achieve the real time data integration. Yeah. So so let me share my desktop. So in this particular what you call real time data integration, what we need to do? So we need to build one sort of service that should be up and running so that as and when the data comes in, we should be in a position to get it processed. That's one way to look at data integration, sorry, real-time data integration. And second, it's not mandated that we go with XML to deal with only real-time data integration. So we can also use it for static data transaction, like just to maintain uniformity of data across all the platforms, right? So in that case also we can go with what XML. For example, we have a data in Windows platform. Can we use same data in Macintosh or some other Unix platforms? Answer is yes. When we go with what either JSON or XML formats. So in that perspective also, there is a need to think of getting into the usage of what XML. So that's another perspective of looking at the usage of XML. So let me try to talk about one simple example where we are going to understand like how to read the data from XML. Yeah. So to do that, we have got one transformation within this what Informatica Cloud, which we call hierarchy parser transformation. Yeah. So let me try to log on, right? Yes. So as we know, as we all know that parser means what? Divide the input data into multiple tokens and start processing each token independently. So that's what we call a token, what we call parsing. Yeah. So now the question, when it comes to XML, you'll have a chunk of data which will be stored in a string. Then string should be split into what? Multiple fields, and each field has got its own business meaning. So we can convert this particular parser definition for what? XML in this way, because XML data, we don't store it in what multiple fields. We store it in one single field, which is a string type with n number of characters, and that particular string will be broken down into multiple parts, and each part would be part of what? A separate business column or business field. Remember that. Yeah. That is a definition of what parser in reality, like how parser will be used in the context of XML. Now, the hierarchy parser, meaning what? Let us say we deal with what? Linear data or hierarchical data. In XML, we can have a data which could be represented in what? In linear form and also in what? Hierarchical form. Yes or no? So now the question, if we take, let us say, we have got what simple XML that is a linear form. For example, let's say we have a root element. Yeah. So root element. So within that, we can have key value pairs. For example, so let's say we have got key which is equal to C1 and corresponding value. Let's say one, sorry, 1, 2, 3. Close the tag. So in this case, can we say that it is hierarchical data? Answer is no. There's only one element at top level. So we can consider that as this as what? Linear data. Now let me extend this. Same thing. Let's say we've got child. You know, then this open tag. Then within that, we can also have corresponding close tag. As we all know that for every open tag, there's a close tag for any markup language, HTML, GHTML, SJS, whatever. So now within this second level, yeah, so let's say key equal to C2 and corresponding value, let's say equal to 2, 3, then close the tag. That's it. Yeah. This is the next level. So this kind of example will be part of what? Hierarchical data. Because this is a level 1. So which one we can put it here? So this is what level 1. This root level. Then this is what? Level 2, which is child level. So likewise, you can also extend this to what? Another level. So within a child, so we can also have what we call grandchild example. Let's say we have a GC, yeah. Then so we can also have what we call close tag for GC, yeah. So then within that, we could able to see what key equal to C3 and value equal to 4, 5, whatever, and close the tag. That's it. This is another level, which is what? Level 3. I'm just trying to talk about how we can represent XML in simple form. Remember that. Yeah. So likewise, so this is what I call hierarchy. So that is why we have got a transformation name, which we call hierarchy parser, which is going to help us in order to read the hierarchical data of this form and start getting it translated to a linear form, which is going to be the relational table or platform data or application data. Remember that. So that's going to be the concept of what? Hierarchy parser. Yeah. Now the next question. I've just given simple XML example, right? But we can have heterogeneous form in the sense some will be in what some column data will be in one level, some column data in what some other level. So such kind of what you call sample data would be part of hierarchical data. Yeah. So that's what we could say as part of this particular what you call semi-structured, we can say. Yeah. Semi-structured data. Fine. Now the next question, if you want to read the data from an XML file, we have to have a structure. For example, let me start with a simple example we've already discussed. If you take a flat file data like a C1, C2, C3, where we have got 1, 2, 3, and then some sample data 456. Now the question, if you want to read this particular data, we have to have metadata. We all know that. Yeah. C1 with a type of integer, C2 with a type of integer, C3 the type of integer, whatever. This is a simple way to represent what? Metadata. We got other properties like a length, the scale, precision, short description, long description, extended meta attributes, and so on. Yes or no? So they're all the what you call attributes of metadata. Similarly, for XML, this is a flat file data metadata, right? For XML also, if you want to read this particular XML data, we have to have metadata. Now, in the context of XML, we can express metadata in what? Multiple forms. Like we got XSD, which is XML schema definition, then DTD, which is a document type definition, or WSDL. I think we have used already WSDL, right? When we talked about web services. Yeah. So, web service definition language. So likewise, you can also see even JSON format also we can have it. Even XML also we can have metadata. Yeah. So any one of these should be considered to be part of what? Metadata. But most widely used one for normal XML is what? XSD, which is what? XML schema definition. Remember this. Yeah. So that's it. Yeah. Now let us try to understand how this particular what I call XSD would look like so that we could able to start what I call processing XML data. Remember that. Yeah. So that's where XSD would come into picture. Yeah. So now let's understand how the XSD would look like in reality. Yeah. For example, let's say we have got a sample data. I'll talk about from realistic perspective here. HP source dot XML. Let me open this in the notepad. Oh, see, here you can see what. So logger, which is a version. So root from derived from wpschools.com. Now can you see here? This is going to be the one of the attribute at root level. What is the attribute name and a value here, not a type value. Now within that, within employee is what? A complex type. Remember, in XML, you can have a simple type and complex type. Yeah. Simple type means this is a simple type. Complex type means example this, where we can have multiple sub elements or sub attributes. Example, so substructure, like within a name, we got a first name and last name. This is the substructure, you can say. This data actually. So once you analyze this particular data, we can generate what? XSD. One, by using what? Third party tools. Like we can use AI tools like ChatGPT, whatever, to generate automatically. Or you can also type it by yourselves. Yeah. So we got multiple AI tools in the market which are based on large language models. Yeah. Like Gemini, we have Copilot, and so on. Right? That's okay. But that's not a big deal. But the main part here is what? Understanding the data. That's it. Now the substructure. Similarly, we can see another substructure, which is a complex type, which is going to be what? Address, where we can see address attributes over here, like address ID, employee ID, line number, whatever. That's what we can see over here. So it is ended here. That's it. So likewise, this is a simple XML example to understand what you call how the data would look like. I gave one example over here. So very simple one. And another simple one we can see in the data, right? Now, for this particular sample XML file, we need to understand what XSD file, because without metadata, there is no way of reading the data. For that, we have got hpemp.xsd. You can see, right? Let's open this. Look at here. There is a root element complex type, which is structure. For every complex type, you will have sequence where you can see what. See here, employee. Look at here. There is an employee, and this is complex type where we can see two elements over here. One employee ID and one more sub element, which is a name. Within again name, can you see complex type and corresponding first name and last name? You can see, right? And ended this particular sequence, ended complex type. Anyway, this is for every open tag, there's a corresponding close tag. So that is clear. So which means name has got sub elements or sub attributes, first and last. This is structure. The type of what? String over here. XS indicates XML schema. The type of string over here. Now we can see dependence based on what address. Address is also what? Complex type. Where we can see again. Look at here. So n number of attributes here. So that we can see over here, like address ID, employee ID, and so on. This is exactly matching with this particular data here. See, address ID, this is the data, right? So this should match with structure. Then only we could able to pull the data from an XML file. That's it. Once it is ready, then we need to, there is a one more simple type here, which is EMP attribute with a type of what? String. That's it. Then close tag all that for every open tag, right? Then corresponding close tag. Finally, it is ended with what? Schema. So open tag will be schema, access schema. So you can see, right? Access schema. It is open there and close at the end. Similarly for element, corresponding close. Complex type, corresponding close tag. That is straightforward. But main concept here is what? Having simple types and complex types. That's it. This example, simple type. This is a complex type. Within that, you can see multiple sub elements. Complex means just like a structure or substructure or sub record. They're all synonyms. Huh? That's it. I hope this concept is clear, right? About XSD, which is a definition, XML schema definition, and we have seen the sample data also. Once this concept is clear, the next step is what? We need to start what? Making this particular XSD that will be understood by IICs. To do that, we need to get into this data integration microservice. Within that, we got a component asset. Can you see here? These are multiple assets, right? We need to go with what? Selecting components aside. Here, so we need to select what? Hierarchical schema. So which means, so we need to create hierarchical schema based on what? Either XML schema or XML or JSON. As we discussed theory, this particular, what I call the structure that could be represented with one of these forms. Yeah. One of them is what? XML also. So our XSD, right? XSD is here. So here we can also see if you want to create hierarchical schema, we can get it created one based on XML schema or based on XML, based on JSON. That's it. Now we are trying to start with what? XML schema. JSON we'll talk about later. Now click on create. Yeah. Any questions from Ajit and Venkat?
No, I'm good.
No, not
Fine. Now let us try to supply the name of this hierarchical schema. So here we are trying to use it for parsing based on what? Two levels of hierarchy, right? So we can extend this to n number of levels. Yeah. So that's it. Now, so we need to upload that particular XSD file because we need to make metadata ready before we start processing the data. Yes, sir. Now choose file and specify this particular XSD file. So go to that location. See this one, right? hpemp.xsd file. Yes or no? Yeah. And then say open. See, there's a root element, and within that we can see the employee, employee ID, name, first name, last name, this first name, last name, then other address attributes within address substructure over here, which contains what? Address ID, employee ID, line 1, line 2, city, state, zip code. Yeah. So that's it. Yeah. And then say, okay. Yeah. So now we can just save this. That's it. Now we made the structure ready. That will be understood by IACS. XSD we have it. We just converted this to IACS format, nothing else. Yeah. Now we can just close it. One part is done. Now, now that we need to make use of that particular structure in order to read the data from an XML file. Yeah. So that is what we need to take a look at. Yeah. Let us try to create a mapping to get it done. Yes. Click on new, select mappings. See, there are lots of things. So we got we got many topics here. Huh? We have just started, right? So click on mappings and say create. Okay. Now let us get what? Hierarchy parser. This one, right? Now, so we need to first refer the component. For that, go to input settings and select a file and click on select. So in this case, we have already created a component. If the component is not created, we can also click on new and get it configured. Yeah. So let's say we are going with what? Let's say someone has already created a component which we are trying to make use of. Yeah. So click on select and go to default. Here you can see hierarchical schema parser with the two levels. This is what we created, right? And then say select. That's it. Yeah. If you want, you can just move it. See, we are pointing to hpmp.xsd. That's it. This is perfect. I can just close it. Next, we need to get the data from the source. To do that, so we need to create one separate file which we call HP sample data or any other name. Within that, we need to specify path to XML file. Can you see here? So this is going to be C source HP source dot XML. Yes or no? So that's what the actual XML file, right? As I said earlier, complete XML data will be stored in a string. Thereafter, parsing would take place. I think we talked about it, right? So, which means now there is a column with the name of path pointing to what? XML file. And this column type will be what? String. So, complete XML data will be stored in a string. Now, let us see how to make use of it. So, go to source, maximize it, select source file connection. Yes. Now HP sample data, right? Let us just searching the file starting with HP, right? So we can select this video button. Yeah. And then say okay. Okay. Now, if you go to fields, you could able to see what path. That's it. Yeah. So this way, one can able to what you call get the path, which is from HP sample data, right? With a type of what string with a precision of 255 characters. If you have more characters, we can get it increased. Yeah. Next, let us try to map this to hierarchy parser. Yeah. Within hierarchy parser, we need to point this path to what? Input to schema definition. To do that, so we need first let us check from the beginning, which is incoming fields, where we can see what? Path. Yeah. So then we have got input field selection. Yeah. So can you see here on the left side, we got a path. On the right side, input. Because this hierarchical schema that we have just created, right? It expects what? A mapping field with a type of string or whatever, right? Now let me try to map it forward. The type is what we know, which is a string. That's it. In case we have done any mistake here, then we can just select this two dotted button and click on unmap. See, it is disappeared here. You can just remap it again. That's all. And precision is what? 32768, which is this many number of characters that we could have it in a XML. That's what it means. After that, we need to start getting into what? Next level of understanding XML. Because now we got from the source, which is a path to XML. Within that, we got a XSD also. This is what XSD, right? Employee, employee ID, name, first name, last name, address, address attributes. See, whatever we discussed in XSD file, same thing we could able to see over there. For example, if you take address, so address is a complex type, right? So within that, we can see multiple attributes or elements. Now, see address ID, all that. So we can just compress this. Similarly, name also, we can just go back here and see name here we got first name and last name, right? Till this. So that also we could able to see over here. Then let us compress this. Then within employee complex type, there is an employee ID. So that also we have seen it here. Yeah. See, within employee, there is an employee ID, the type of short. Yeah. So that's also over. Next, there is a EMP attribute, which is an independent, what you call element. So that also we can see over here, which is in the bottom, I think. Yes, EMP attribute with a type of what? String. That's it. All are covered. Whatever is there in XSD, all of them can be seen here. Yes or no? EMP details is what? Root. Under root, we have seen EMP details. See, under root, we can see EMP details. See, same structure as we could see in this particular, what I call XSD. Yeah. So root, EMP details, then simple type, then followed by complex types. Now, if we try to expand this, we can do it again one by one or one shot by using, let's say, if we compress all will be compressed. If we click on plus, all will be expanded, whichever you are comfortable. After that, we can also search whatever element that you are looking for. Let us say we are looking for only address. See, address starting with this particular set of characters, only those elements can be listed over here. If we just take out this, then we can see all of them. Similarly, on the right side also, we can see what? Relational or denormalized data. For example, now let us say we need to convert this particular XML data to relational. So in that case, can you see? Click on root and select what? Map all descendants. So all the fields from the hierarchical structure would be translated to relational, which is on the right side. Yes or no? We could able to see it over here. That's it. Yeah. Now let us map it. Map it to what? Target. See EMP details, right? Which is a root element. Under that only we got employee substructure, address substructure, name substructure. We have seen what? Three substructures or three complex types. Yeah, that's it. Now say okay. That's it. Now we need to configure the target as well. Yeah. Yes. Okay. So now we can see here what hierarchy parts are. Parser for what XML we are trying to parse, which is which will be converted to text as a text file dot txt. Which means you're trying to convert XML to text with a parsing logic. Which means parsing means take a string data, divide that into what? Multiple fields. Or we can also say that parsing follows what? Tokenization process. Tokenization means divisioning of input data into multiple parts, and each part would be read independently. Yeah, fine. Say okay. Now specify the mapping name. Yeah. So mapping underscore what hierarchy parser. So better to give meaningful names because just by looking at the name, we should be in a position to understand like what we are doing. So XML to text or relational. Yeah, relational is the best thing. Relational could be text file or it could be table or it could be even application. Yeah, save it. Okay, now let's run this and monitor this. Okay. If you have any questions, you can just ask now. Venkat and Ajit.
So, like whenever we are importing this XML source, right? So the XST structure will come along with the XML files, or like should we separately generate that XST file?
Yes, second part is right. We need to create XSD based on XML. So XML data, we get it from the business. To read it, we need to create XSD by ourselves. Venkat. Yeah, that is very simple. As I said, we can use a lot of tools. We don't need to think too much. Or Google also can
Okay.
use it, or AI tools. We can just supply
Yeah,
XML data
tools.
as in it will generate
Okay.
XSD Venkat automatically. Yeah,
Okay. Okay.
yeah, it is that simple. Okay, so let us try to refresh it. See, it is processed. There is only one row, right? So in XML, let us say the data. I will compare with the actual source data. Yeah, the first thing is what? EMP attribute with a value of what? String. Let us see that. Yeah, see here, EMP attribute with a value of what? String. That is over. Next, we got employee ID, which is 1, right? Yes, employee ID value is what? 1. Then first name, which is Arjun. See, first name, which is Arjun. Last name, which is Sinha, right? So Sinha, right? Last name. That's it. Name is over. Now we need to get into address. So address ID 2, employee ID 1. Let's see here. Address ID 2, which is this. Employee ID, address employee ID, which is what? 2. Then we got a 2, 1. Sorry, employee ID is what? 1. Because this is derived from here, right? Because one-to-many relationship between what? Employee and address. That's how this hierarchy will be built, right? So, like, let's say there is a master element which will have a number of childrens. Like, for that, we need to build a linkage between what? Parent and child, or primary key of one top level element that will become as what? Foreign key to child element. In this case, this is employee. For every employee, a number of addresses, and the linkage with what? Linkage with what? Which is 1, which is address employee ID. Next, line 1, we can see Bagman Tech Park. This one, right? And then we have got line 2. So, which is going to be CV Ram Nagar. Yeah. Here also you can see same thing. Sun City is Bangalore, and then state code is Karnataka, KA, Bangalore, and KA. Then zip code and date also we can see here. So yes, zip code and from date. This is a zip code. This is a from date. Yeah. So that's it. Yeah. That's all. So with this, I think we understood end to end, like how to read the data from an XML file by using what? Hierarchy parser transformation, and how we could able to convert XML to what? Text. Yeah. That's it. Like how this particular hierarchy parser transformation works. Yeah. Source is one row, target is also one row. So it got transferred successfully with all the fields without any data truncation, right? So we have seen that. I hope it is clear, right? So I made you guys clear to
Yeah.
understand from the beginning till the end. Yeah, yeah. So that's it about XML to text. The next is what other way? In the sense, let us say we got n number of flat files. N could be one or two or three with their interrelationship. For example, there could be one file which is a master file. There could be one or more other files which are what children's. Yeah. So that's a question. Yes or no? So how one can start taking care of what I call reading the data from what I call these kinds of relationship, master child flat files, and how we can convert this flat files data to what XML. We just did XML to text example. Now text to XML. Text could be represented with a single file or multiple files. I'll talk about with multiple files. So single file is a subset of that, right? So that will be covered anyway implicitly. Yeah. So that part we will talk about it in the next session. Yeah. So what we need to do is, so we'll try to install this software on your system so that probably tomorrow, day after tomorrow, we'll do that so that you can also start getting into hands-on stuff, right? Is that fine, Ajit and Venkat?
Sure. Yeah, that works.
Yeah, yes.
So we'll do that tomorrow, day after tomorrow. Let us see. We just started, right? So that's all for today. So thank you very much to both of you. And bye.
It's the same time, right? Tomorrow also?
Yes, same time, 7:30 a.m. Yeah.
Okay.
Venkat, it's the same thing. Yeah. So okay, right?
Yeah, yeah.
Venkat and Ajit.
Yeah,
Yeah, I'm
okay.
fine. I'm fine. Yeah.
Okay, I'm fine.
Yeah. Okay. Thanks to all. Bye.
Yeah, I received your email with all the details. I will
Sure,
do
Venkat.
that tomorrow. Okay.
Okay.
Yeah.
Okay, Venkat.
I didn't check my
Thank you.
emails
Bye.
like last 2 days. I was out of town. Yeah.
Okay, that's fine, Venkat. Yeah.
Yeah.
Thank
Sure.
you.
Thanks.
Bye.